Swayam Prabha. Digital India. Educated India.
Let's get today's class started. So we'll continue to look at stocks and flows. To introduce you to the two key concept of building a system dynamic model, which is identifying your stocks and flows. Stock is represented as a rectangle and flows are represented by thick arrows with valves in it. Direction of arrows shows whether we are adding to the stock or removing from the stock. And whatever we add we are calling it as inflows, whatever we remove we are calling as outflows. And it is important to note that the underlying equation to this graphical representation is nothing but a differential equation, where the change in stock over time t is nothing but inflow minus outflow. This is also known as net flow at a particular point in time. If you want to actually see what is the say change in stock, so change in stock, that is d of stock, can simply be delta t times your inflow at time t minus your outflow at time t. And when we are actually saying trying to simulate it, what we are, so this dt represents your time step or time time step or time interval, and we are measuring the change in stock during that particular time, and that's amount of stock that is changed from its previous value, that is amount added or subtracted from the stock. So let's try to look at an example on looking at a description how to identify the stocks and flows and construct a diagram looking at stock and flows. Then in today's class we will say that if the inflows or outflows behaves in a particular fashion over time, let us try to graphically figure out how the stock changes over time, so that we get a feel of how the simulation itself is expected to work. Because many times what happens is when we start moving into equations, we kind of just blindly trust it, and but before that we need to build intuition. The best way to do it is graphically and trying to see what kind of behavior we can expect over time. So that's the agenda for today's class, first part of the class. Let's move on to the examples. Let's look at a scenario. We looked at few examples last class to identify stocks and flows. So today we will begin with an example of just mapping the stock flow diagram, schematic representation of a model. Okay. So the description, using the same description you can model a causal loop diagram. We have seen some examples of that last week. But we can go one step further and start to identify what are the stocks and flows within the same based on the same description. Let us take a very more straightforward example where many things may be physical. So let us start with that. A manufacturing firm orders raw material from outside, which it processes and produces finished products. The firm maintains inventory of finished goods from which it ships to customers. Customer order when received is not immediately fulfilled. There is a delay caused by order processing, credit checks, etc., after which the order is fulfilled, subject to availability. Okay. So this is the very brief description. So what all could be the stocks in this model, in this scenario? I think the example is quite easy to remember. All we have is company gets raw materials, then it produces and makes finished products, and when customer makes an order, they keep it in backlog while they are doing all the various checks, and then once it is done, it is shipped. So we identified three stocks. Raw material inventory, finished goods inventory. Oops. Then let's have something called as a customer order backlog. So this is the example. So these are 3 stocks we have, and the description starts off saying that manufacturing firm orders raw materials from outside. So we can, or rather we need to have a flow which is coming into the raw materials, right? Otherwise how is the stock going to change? So we need to have a flow, we can't have anything else, we have to have a flow. So that will be the rate at which I am going to be procuring materials. So I can call it as I am using RM for raw material procurement rate, and raw materials I am going to use the raw material to make the finished products, right. So logically there must be some production process that is happening which converts these raw materials into finished products, and based on, and there has to be some conservation, right, based on the raw material use I produce finished products. So I can have a single arrow like this, called as production rate. Again note, all arrows need not start with a cloud. Cloud means it's like an infinite source, whenever I order it keeps coming. It's almost it's a kind of at least in this model looks exogenous. But production rate is going to remove material from the inventory and add them to this finished good inventory. So it is going to remove, so material in that way is conserved. That was one of the states we told, for stock it gets conserved. And from the finished goods, we are going to have something called as shipment rate. Just observe how I have given the variable names. Whenever there is a flow, we just told flow or rate or flow rate. Just to ensure that we do not make mistakes in units, we can always say RM procurement rate, production rate, shipment rate, or you could have just used the word shipment or production, but then we get confused with units. So it is always good to rate shipment rate. So whenever you say rate, it means units over time, right. So it helps us doing that. It's also good to think in terms of some of the units. So procurement, since no other information is given, just for example we can take it as say pieces per week, could be the units here. If this is the units here, then the same units has to be here. You can't have any other units. It has to be pieces per week, and I am arbitrarily chosen the time units as week. If you day, then make it consistent using day. Then the raw material units is pieces. Inventory unit is also I am counting in pieces. Or if you measure in tons, you use tons. If it's kilograms, use kilograms consistently. Whatever the units, if it is in cases or if it is in some sort of stock keeping unit, then you use the same units appropriately. The idea here is rates is there is a per unit time, and others it just has pieces. So this is the physical flow of the material that we have captured. The second part of description dealt with the information flow. Okay. So what we have is customer order, there is backlog. What we have is customer order rate. So as more orders come in, the backlog is going to increase. So we can just call it as order rate, and as we start fulfilling orders, that orders rate is going to go down. So order fulfillment rate, the rate at which orders are fulfilled. Just a side note, let us call it CLD note. If the same thing I want to represent as a causal loop, the top part, how I will write it is like this: RM procurement rate, then let us call it raw material inventory, and let us call it production rate. I am just going to give one example, you can extrapolate it for others. So, here as raw material increases, my raw material inventory is going to increase, correct. So, direction is the same. So, I get an arrow like this, but as production rate increases, my raw material inventory is going to fall down because I am going to consuming the inventory. So, the direction of arrow will be like this. So, when you see descriptions like this, so this negative arrow, I mean the arrow with a negative causal direction is denoted by an arrow, outgoing arrow here, okay. So, you can see this image in contrast with this. You will get similar thing here like order rate, customer order backlog, order fulfillment rate, exactly similar linkages, right. If you want to add a finished good inventory, the production rate will have a plus sign to finished good inventory, and then it will have a if you want to have a finished goods inventory, shipments. So, this is exact causal link of this one, but this when we start moving to causal stock flow diagram, it captures some more information, that is the flow of material is conserved here automatically, but here it looks like production rate is, I can have a very different equation for inventory and this, and it can affect both in a different ways, right. That is not very intuitive here. So, when you do it here, you are grounding it a little more into what actually happens. Let us go now back to the stock flow diagram. So, I am just trying to illustrate how the CLDs can be translated into a stock flow. Now, this model is not finished. One way to check that is how we are getting the order rate, just to make our life little more interesting. So, order rate, suppose we measure it as orders per week. So, then this has to be orders, this also has to be orders per week. This flow is now conserved, this is also orders per week, this is also orders per week, that is a unit of measure I have. But now I have to link these two, I have shipment rate and I have an order fulfillment rate where the units do not match. So, I can't just say that order fulfillment rate equals shipment rate and model the equation. What else, what do we need? The average size of an order or average number of pieces per order. This is just a simple variable I need, based on which I can link these two, okay. So, I can have another variable called as average pieces per order. So, now what all should I link? How will intuitively what we expect to do, I mean, without going into the equations, it is difficult. See, every week, imagine what do I do? I look at the backlog, okay, this is the backlog I have, then what is the average number of pieces that it demands, okay, this is the total pieces I need, then I look at the inventory, do I have enough piece, and based on that I decide how much I should ship, correct. So, to decide on the order fulfillment rate, I need information about say the customer order, average pieces, as well as current inventory, right. If inventory is more, my fulfillment rate will be higher, so I can have a plus. These are anyway some constants. So, now I got an order fulfillment rate, and based on whatever the order fulfillment rate, the same rate I will do the shipment. So I can write an equation simply stating shipment rate equal to order fulfillment rate or something. There are two arrows here, one is shipment as well as average pieces. So this arrow here represents that customer order backlog information is used in computing order fulfillment rate. So this thick arrow only indicates that backlog uses this information of customer order fulfillment. This thick arrow only represents this line. Okay, I have not drawn it. Only represents a line between order fulfillment to customer backlog. So if I want another line, I have to draw it explicitly. But to start with, it's okay. Once you go into equations, you will automatically start doing it. Our system will prompt you that it will connect the arrow for you. For now, all you have to understand is we have defined two stocks and flows. There is one auxiliary variable which actually connects these two information. So this arrow here looks quite messy. At least initial model, it need not be so messy. Even if you are connected at one place, it's fine. We are not looking at accuracy of the model yet, as long as there is an extra variable here. So units of it will be say pieces per order. That's the units. So that we can do all multiplication, addition, or whatever it is we want to do, figure out the calculations. So in this, if you want, since you are practicing, I can tell you this is an important link, this is an important link, and this is an important link. If you have captured these three arrows in your model, that's sufficient. The other twos are optional. If you have figured it out, it's good. If not, you will get it by practice. Don't worry about it. So this arrow indicates that I am using this information here, so it is important. This arrow indicates that this and this are connected, so it is important. And this is an extra information I use to connect these two. So that information also somehow used in this calculation. So that's all it says. So after that we can, at least those three arrows are minimum required to have a decent model. Again, as I mentioned, clouds indicate an infinite sink or infinite source that marks the boundary of your model. Whatever happens to that afterwards, we don't care about it. Like it is already shipped, that's all I worry about. As long as it's left my premises, I don't care when it reaches the customer yet. If it is required, then we capture it. If not, that marks the boundary of your model. No, there is extra delay that is described in the described here. Customer order when received not immediately fulfilled. If you directly connect it, that means you immediately fulfill. That's what I'm saying. As long as an order comes, it's not immediately fulfilled. That's what the description says. There is a delay caused by order processing, credit checks, etc. So there is some delay in there. So to capture the delay, we are modeling a stock. So while they end up doing that, so after some time only, the order is ready for shipment. So maybe 1 week later.